Welcome back to our third and final segment. We're still looking into the game that matters in terms of the physical properties. So up to now, we've managed to identify, some of the possible options which are definitely not related to what substance X is. Now let's look at more clues. In the previous segment, we spoke about solubility as a property of a material, in terms of it dissolving to form a solution, whether it's completely soluble or partially soluble. So solubility is the extent to which a substance dissolves in a solvent to form a solution. Now, if a substance does completely dissolve, then it's soluble, while if the opposite happens to a smaller extent or not dissolving at all, then we'll describe that substance as insoluble. All right, so solubility, we are saying that sulfur is insoluble in water. So sulfur actually does not dissolve in water, okay? And silicon is also insoluble in water. Chlorine dissolves completely in water, hence we're saying chlorine, it's soluble, while sodium chloride is completely soluble in water. Okay, where does this lead us? It says to us that definitely sulfur and silicon are definitely not are not exactly what we are looking for in terms of the identity of substance X. So we're left with two, okay? The reason why we took out sulfur and silicon is based on their solubility, okay? Right? Is based on their solubility. So if something is soluble, it means it dissolves completely. Now we're told that X dissolves completely in water. Now, if we look at sulfur and silicon, which silicon is a semi-metal while sulfur is a non-metal, it says to us that these two cannot be substance X, right? Moving along, then the other keyword that has to do with electrical conductivity. When we talk of an electrolyte, right? An electrolyte is actually an ionic substance that is dissolved in water, and while it does that, it will allow electricity to pass through. So an electrolyte is an electrical conductor. So let's keep that in mind as a property of solubility, right? And then it says here, if a substance is an electrolytic solution, let's look at sodium chloride as an example. A sodium chloride solution is a good electrical conductor, okay? So it is an electrolyte. So we'll describe it as an electrolyte because when dissolved completely in water, it allows electricity to pass through and then it becomes a conductor, right? Then a chlorine solution is a poor conductor, meaning that it is an insulator, right? And then we're definitely going to take out part of the chlorine, because chlorine is a non-conductor, because this is an insulator. Yes, it is soluble in water. So, but at the end of the day, this is an insulator. Okay, it is an insulator, right? While it is completely soluble in water, it does not allow electricity to pass through it. Now, we're onto something here. Now, we are saying that substance X has the properties like the NO 6. Then we are saying that after eliminating 5 of the possible 6 options, we're left with only one option, which is sodium chloride. Then it simply means to us that X is indeed sodium chloride. But how exactly did we arrive at that? We appreciated the fact that we need to understand the physical properties. We went to the periodic table, we looked at the trends, at the periodicity, we understood that materials or substances that fall within the same group, they've got similar physical properties, while if we consider the horizontal rows, which are the periods, the physical properties will differ, okay? Right, now, having said that, let's understand something about sodium chloride based on the physical properties. One thing for sure, sodium chloride is a compound. Why is it a compound? Because it consists of 2 different materials or 2 different substances that are chemically joined together, which is a metal, which is sodium, which is a metal, okay, while chlorine is a non-metal, okay? Now, this is a compound in the sense that it's a combination of 2 different elements joined together. Hence, we would classify sodium chloride as a typical compound. It is a poor electrical conductor. If something is a poor electrical conductor, we are saying it is an insulator, okay? Poor electrical conductors are actually good insulators as a solid, but good electrical conductors, it is an insulator as a solid. Why? Because it consists of ions, but if these ions are not moving, then electric charge cannot be transferred through it. Now, in other words, we are saying it becomes a good electrical conductor in a fluid, which is a liquid or a gas. So that's the whole idea about sodium chloride. And furthermore, we are also saying that in terms of solubility, it dissolves completely in water to form an electrolyte. Remember, electrolytes are only formed when an ionic substance completely dissolves in water, and then these ions are free to move through it. We'll talk about electrolytes more in detail as we look at the periodic table at a later stage, right? And then also, the microscopic in terms of the particle nature of sodium chloride. It consists of ions of chlorine as well as of sodium. So chloride ions have got a negative charge, okay? So these ions, we call them N ions. Any ion that has got a negative charge is called an N ion, while those that are positive is called a cation, right? So this is the chemical composition. So in other words, we can simply say that sodium chloride is an ionic solid. So if we say it's an ionic solid, what does that say to us? It says under normal circumstances, we find it in solid form, unless of course it has been dissolved in water. And now that tells us that sodium chloride is actually completely soluble in water as far as solubility is concerned. Right, okay, what more? Substance X is an ionic solid that contains chloride ions. Now we are told, okay? Now that's another clue, okay? We're going further. Now we've identified X. Now we at a different stage, we are saying, okay, here's another substance, which we still call it X because it's unknown. It contains chloride ions, okay? That's the first clue. So substance X has properties like one of the 6 that are given, okay? There are also no particles in X that are not present in the 6 substances. What does that tell us? It tells us that all these 6 substances that are given as possible options of what X could be are actually consisting of particles. Now, our job is to, our task is to establish the identity of substance X, right? Okay, now, substance X could be a combination of one of the more than one of the 6 substances that are given. So if you come to think of it, copper and chlorine, a combination of these 2, if they react together, they can form a substance, okay? That substance is actually copper chloride, which is in solid form because it has similar properties to those of sodium chloride, because what is common is that both of them, they contain chlorine. Take note, the name is chloride. Okay, not chlorine. It means chlorine is a component of this compound, okay? And what is a compound? It's a combination of 2 substances that are different and they're chemically joined together, copper being a metal, while chlorine being a non-metal. So that's what has been consistent in terms of the composition, right? And then again, we are told that substance X is copper chloride, okay? It's given. Now, a blue or blue-green solution indicates that copper ions are present, because if this substance completely dissolves in water, it forms that homogeneous solution, which is actually blue in color. And the color indicates the presence of copper ions, okay? Right. And then, in summary, what are we saying? Matter can be classified into different groups based on physical properties. So one cannot overemphasize the importance of us understanding the physical properties of material so that we are able to classify them or categorize them in whatever it respects in terms of, their behavior, the packaging of materials, but the physical properties are very central in as far as the periodic table is concerned. So to find materials or elements within the same group, because they show or they display similar properties, that's what is important in as far as, the physical properties. So elements are arranged in the periodic table according to their properties. We've mentioned that, okay? So properties of matter are explained by studying the microscopic model. So when we look at the chemical composition, at a particular level of a material, we are able to understand its properties, because how a particular material behaves or, whatever happens to it, is based on how these particles are arranged. It could also relate to, the state in which it occurs under different conditions. Can it be a solid, liquid, gas? Does it dissolve? Is it able to, conduct electricity? Is it a thermal conductor or insulator? All those are actually based on the microscopic, composition of that particular material, right? So it's very, very important for us to understand that. But over and above, we are saying that the periodic table of elements, is arranged in such a way that substances are in an order of sequence, in terms of their physical properties. So very, very important is that, if elements or substances fall within a particular group, they more or less show the same physical properties. So there is a special, sequence in the periodic table, something that we'll look into detail in terms of what we refer to as the periodicity or the trends, the patterns in terms of the properties, right? Okay. Now, in the sense of understanding the periodic table, we are saying that the main idea is to understand the physical properties of materials. So once we are able to identify a particular material and be able to speak to its individual properties, we are able to understand further the applications of that material in terms of the everyday life use. So it all comes together in as far as the physical properties. Hopefully it does make sense, but the idea is to also, given a material, you must be able to say, okay, this material, is it a pure substance or an impure substance? Is it an element or a compound? If it is an element, in which group does it occur? And then in which period? Particularly with the group, it also becomes important in terms of the physical properties within that particular group. For today, that's as much as we can cover in as far as the physical properties of material. From myself, Temba Ncube, cheers and bye-bye.